Hey guys, welcome back to another video, and today we'll be discussing about alpha beta pruning. So in the past video we talked about min-max algorithm, and alpha beta pruning solves one of the problems of min-max algorithm, which is let's say you have to find the max value here and you look into 2, so you put 2 here but you're still looking into 1 to find out if that's the big value. However, you already looked into the highest value here, so looking into 1 here would be a waste. So what alpha beta pruning does is it makes sure that there is more efficiency in terms of searching for the best results. So similarly as min-max algorithm, we have max and min values. So the top or the root value is always the max, and the min then the max, and that goes on. So in alpha beta pruning, we have alpha, which represents max value, and we have beta, which represents the minimum value. So the max is always like minus infinity, would be the worst case, and the beta is the positive infinity, which could be the worst case for beta in terms of main values. And when we are going to prune, so pruning means we are going to cut one branch, is when the value of alpha is greater or equal to beta. So let's just look into the example and see how it works. So one thing that you have to remember in alpha beta pruning is that it follows the DFS procedure in terms of looking for values. So we are going to look into here, so look into this leaf node, then go to look into this, and so on. So alpha is, as I said, negative infinity, and beta is positive infinity, and the value of alpha beta flows down to its children. So our task here is to find the max value, and of course 6 is much better than minus infinity, so we put 6, and we are looking into 5, so 5 is much better than, not better than 6, so we are not going to look into that, and that value goes up to its parents. In the parents we are looking into the minimum value, so which one is better, so positive infinity or 6, which is lower? So of course 6, we are going to put 6 here, and this whole value flows down to this side on the right hand side. So alpha would be negative infinity and beta would be 6 for this node. So we have to find the max value here, so 8 is much better than minus infinity, so we're going to put 8. Now if you look here, we're going to see that alpha's value is much greater than beta, so we're going to prune this branch, meaning that we're not going to look into 9, and the value goes up to its parents, and the parents have to look for the minimum value. So which one is better, 6 or 8, or the value that we have? The value that we have is better, so we don't have to change anything, the value goes up. And in the top or the root node, we're looking for the max value. So is my negative infinity better? No, 6 is better, so we're gonna put 6 here. As I said before, the value flows down, so alpha would be 6 and beta would be negative infinity. Similarly here, alpha is 6, beta is infinity, and the task here is to, in this level, is to find the max value. So 2 is not greater than 6 and 1 is not greater than 6, so nothing changes. This value goes up. Here we're going to find the minimum value, right? So what is better, positive infinity, 6, so 6 is much better, so we're gonna update this value, and this is what happens. So alpha's value is equal to beta, right? And our condition was alpha has to be greater or equal to beta to prune. So we satisfied the condition, meaning we are going to prune this branch, and we are pruning this branch, so meaning we are not going to look into these values either. Now the value goes up to the parents, and we are finding the max value, so 6 and 6, and we already have 6, so nothing to update here, and this is the whole result. Remember, in alpha beta pruning you have to write the values of alpha beta in every node, and if they ask you to find the best or optimal path, that is the value that we got at the top, so or the root, so which is 6 here. Where did we get the 6 from? So we got the 6 from here. So this is the path that we are going to say as optimal. So you can put in the name the nodes whatever you want to better identify the optimal path, so that the path would be basically D to B to A. So hope you guys did understand the concept of alpha beta pruning, and it's quite easy. Do practice hard examples or bigger examples to better get the idea of what it is. And if you have any questions or suggestions, feel free to comment down below. Thank you.